Have you ever left sensitive personal data sitting unencrypted on your local hard drive, hoping nothing goes wrong? Today, you will build a robust Python script that automatically locates and encrypts your private files using industry-standard cryptography. Welcome to this hands-on screencast on automating file encryption in Python. Protecting personal data like financial spreadsheets, private journals, or API credentials is critical in today's digital landscape. Instead of relying on manual encryption tools, we will leverage Python's built-in libraries to build an automated pipeline. By the end of this session, you'll understand how to generate cryptographic keys, securely read local files, transform plaintext bytes into encrypted ciphertexts, and restore them safely when needed. Let's dive in and start building our secure file processor. Before writing code, let's look at how symmetric encryption works. Symmetric encryption uses the exact same secret key to both lock and unlock data. If an unauthorized person gains access to your encrypted file, they see only scrambled bytes without the key. In Python, we will implement this using the standard libraries secret generation and basic encoding patterns, ensuring our sensitive information stays completely private even if our backup storage is compromised. Every secure system starts with a strong cryptographic key. Here, we write a self-contained script using Python's built-in secrets module to generate a secure random token and save it to a local file named secret.key. This key acts as our master password. Notice how we open the file in binary write mode to safely store our raw byte string. Managing your encryption key safely is just as important as the encryption algorithm itself. If you lose your key, your encrypted files become permanently unrecoverable. Conversely, if your key file is left sitting right next to your encrypted data with zero access restrictions, the encryption offers very little real-world security. We must keep our key generation process isolated and treat the key file with utmost care. Now that our key file exists on disk, we need a reliable way to load it back into memory whenever we want to encrypt or decrypt data. This script reads the binary contents of secret.key and makes it available as a Python bytes object. We encapsulate this inside a clean function so other parts of our application can fetch the key effortlessly. To keep our demonstration simple and dependent only on Python's standard library without external dependencies like cryptography, we will implement a lightweight bytewise XOR transformation cipher. While production systems use AES, the XOR cipher clearly demonstrates how binary data manipulation works. Every byte of the input is combined with a byte from our secret key using the XOR operation, which is completely reversible when applied a second time. Let's write the complete file encryption function. We read a target file in binary mode, iterate through its bytes, and apply our repeating key using zip and the XOR operator. Then, we write the resulting scrambled bytes to a new file with an encrypted extension. This completely protects the original contents from prying eyes. Writing scripts for single files is helpful, but true automation means scanning entire directories for sensitive patterns. We want our script to automatically find files matching specific extensions, such as .txt or .csv, and encrypt them in bulk. Let's review the automated workflow stages, from discovering target files to processing and cleaning up leftovers. Here, we use Python's built-in pathlib library to recursively search a directory for all text files. Pathlib makes handling file system paths across different operating systems trivial. Our script lists each discovered file, preparing it for our automated encryption batch processor. Encryption is only half of the equation. We also need to be able to recover our data when needed. Because our transformation is symmetric, running the exact same byte-level XOR process with the identical key restores the ciphertext back into readable plaintext. Understanding this duality ensures our automation scripts remain fully reversible and safe against accidental permanent data loss. Let's put everything together into a complete, self-contained automation script. This script generates a key, creates a sample-sensitive file, encrypts it automatically using our scanning logic, and then successfully decrypts it back to prove the round-trip works seamlessly. This is the exact pattern you can schedule with cron or task scheduler. Congratulations! You have successfully built an automated file encryption pipeline in Python using only the standard library. You now know how to generate secure keys, manipulate binary file streams, and design reliable workflows for your sensitive personal data. Feel free to extend this script with robust logging, stronger encryption algorithms like Fernet from the cryptography package, or scheduled cron jobs. Thanks for watching, and happy coding!